Here's how we defined our generalized projection operators, and now we always use unitary irreps. So instead of this gamma inverse here, you can write a gamma complex conjugate with the indices here swapped. Now, last time we showed that if we apply these generalized projection operators to some psi in our vector space, and this psi can be expanded in such an irreducible basis, so the e's here are the irreducible basis vectors and the c's are just complex numbers, the coefficients, then we get, if we apply p mu j k, we get e mu k, so that's these indices here, and the coefficient in front of it is the c mu j, so that's what the j here picks. Good, so that we know already, and now we see that this immediately proves property 1. So either the c mu j is 0, then no matter what we do with the k here, we always get 0. So we get d mu vectors, 0 vectors. But if the c mu j is non-zero, then we have the same coefficient here, and we go through all the basis functions for this representation, gamma mu here. So we get something that transforms in this irrep. So that was our property 1 here we showed already last time. Now the second thing here, this one, we can just calculate. So let's take p mu ji, p mu lk, and apply to some function psi as written above. Copy the p mu ji, and now the p nu lk, that picks c nu l, e nu k. Okay, but now the term in the middle is just a number, which we copy, c nu l, but what happens to the rest? We now pick the coefficient, coefficient with the mu nu, but there is only one term here. This is not an expansion anymore, so this is only non-zero if mu is equal to nu and if j is equal to k. We have a delta mu nu, a delta jk, and the result is proportional to e mu I. Okay, now let's use this delta here in order to change this nu into a mu up here. So we have a mu here, and now we have c mu l, e mu I, and we use this property here again, and we have delta mu nu, delta jk, and that's just p mu li applied to psi. And now we showed that this one here is equal to this, and that's exactly what was written up here.